Do you have any problem with the collision handling code? Any question on the source code or the example? We are on good. No, no question whatsoever.
Hello, teacher. I have a question.
Mm-hmm.
May I share screen?
Sure.
I don't know why, but when I run the sample 4 and I hit the button A, and then the key code will 30, right? And then I hit the button A again, and will appear 40. And I hit again, it's E 40, and I hit again, it's E 30. I don't know the reason why, actually.
Probably because of your wiki is on. Because when you hit A, so with the telex typing, it interferes with the keyboard code. Turn it off.
Okay, I will turn it off and try one more time.
Yeah.
I just turn it off.
Run again.
It seems to be work. Okay. And I has a other question. Like on the cohesion framework. In first case, we will check if the column H is not known.
It's not column. It's collision on X and collision on Y, right?
The cohesion on H and cohesion on Y, if they are both of them are not known, we will jump into this, and then we will check if cohesion on H is not known, we will jump into this, and cohesion on Y, if it's not known, we will jump on Z, and if both of them are known, we will jump on Z. But when both of them are known, it means that cohesion event we were equal to 0. So
no, they are not. No, they are not. Because filter is for filter blocking event, right? So if there is no collision at all, so for example, if you collide with a coil, so the filter function does not filter out the normal collision. It only filter the blocking. So if Mario collide with a coin, there is collision, but there is no blocking collision. So blocking collision means you cannot get past to the object you collide with, right?
Yeah. Okay, thank you.
Is it good, clear?
Yeah.
Bro, you need to pull your new code from teacher, because I think that's the old code. Just tell you so.
Oh, actually, I have just upload the latest code for the sample 5, the last one, the finalized one. So yeah, let's pull down the latest example. But in terms of code number, example number 4, I don't think I changed anything except that except the change to
the
blur.
Yeah, the blur and for Goomba, yeah.
Oh, Goomba, yeah. Okay, so we have 31 joining. I think we have students from both classes, right? Can you, one of you guys, say that you are coming from the other group? Anybody from the other group?
From the other group.
Okay, good. So Lap is on the other group. Okay. So do we have anybody who want to turn on the camera?
Not yet, sir.
Yeah, I think I need someone to turn on the camera with the. Okay, Khoa again. Thank you, Khoa. Somebody else would be great. So why we have to just look at one face every time? Sorry, no offended. Just kidding. Okay, so I have one question here. After the camera lesson, can you break down the code of both collision and camera? What do you mean by break down the code of both collision and camera? Nam, what do you
Which
mean?
Just it explains some code inside the collision file. I see that the collision file has a camera.
No.
I mean in the the PowerPoint slide in the slide, you have collision, then you have the camera.
Oh, okay.
Yeah.
So actually, they are not together. They are different topics, but it's just so small. So I don't want to create a one slide with one presentation with only one slide. Camera is actually super simple. So yeah, just put it there. Okay, so let's start with the camera lesson. The camera code is actually super simple. The idea is super simple. So we just need to look at the slide and you will understand why we have such a code. Okay, do you see my screen now or no? I'll show it again. So see my screen? So let's say we we have an object. We have an object here, right? So the coordinate, the location of the object inside the world, inside the virtual world, is x and y. Okay. So and we want to draw the object onto the screen, right? And so we want to know where on the screen we should draw the object, right? So let's say the location of the object on the screen coordinate is x plus and then y plus, right? I don't actually know how to say the plus sign over here in English correctly. X minus or y minus or something like that. So okay, so okay, to make it simple, so I make it xc and yc. Okay. Are you still with me? So so xc and yc are the value that we need to find out, right? Because we want to know if the object is at location x and y in the world coordinate, and we want to know where to render it or where to draw it inside the screen coordinate system or inside the screen. So which means we need to figure out how to convert x and y to the xc and yc, right? So in order to know that, so we need to know the coordinate, the top left right corner of the screen, right, itself, right, inside the work coordinate, right? So how do we know the screen, the X camera and Y camera, which means are the top left corner of the screen inside the work coordinate? So it's all up to us, right? So we can basically this location, the X camera or and Y camera is on up to us where we want to point the camera to. Okay, so it could be looking at the character, the player, or it could be looking at somewhere else inside the world, inside the world, right? So it doesn't have to be a strict rule, but to make it simple, usually we let the camera to focus or to look at a position relating to the current player. Okay, so let's assume that we know how to calculate the X camera and Y camera based on the current value of X and Y. Okay, so because at least we know, because we can make up the rule. So let's say if we know the X camera and Y camera already, so how do we calculate the XC and YC over here? So it's pretty simple, right? So you just get the X, you minus for the X camera, and over here the same. So you get Y. Sorry, you get the Y, you minus to the Y camera over here, and you got the X, right? You minus to the X camera, and you got the and you come up with the XC and the YC value, right? The XC is actually from here to here, the YC is from here to here, right? So it's just a simple geometry calculation, right? Just get the X minus to X cam and get the Y minus to Y cam, and you get the formula. With me? So that's the calculation over here. So I'll go over the sprite and then add the drawing function. So you know that we just minus, but over here why there is a plus? Because the work coordinate system in the graphic engine is actually in the reverse order, right? So instead of minus, we plus. Okay. So but if in the normal orientation, so you just get the X, right? Is the position of the object, and you minus to the camera, and then over here, so you minus. Okay. Are we good? And then you know where to draw. So that's all about camera. But how do we come up with the X camera and Y camera over here? So in my example, the rule is pretty simple. So you can see that over here, I'm always trying to put the camera at the center and make the object, the player character or Mario, to be the center at the screen. So like this, I'm trying to put Mario in the middle of the screen like this, and then I calculate the X camera and Y camera based on the X and Y of Mario. Okay. And that was why we have this formula, right? So first of all, we get the position of the player, right? So and then we add it into the CX or CY camera, and then we just minus it to the half of the screen size on width, on height, right? So we started at the object here, right? Because the object is the Mario is at the center of the screen, so we get the Mario position, right? And then we add half of the height and half of the width of the screen so that we come up with the X cam and Y cam over here. Got it, guys? So that was why I minus, right? And after that, the CX value and CY value. So we set the camera pose. Over here, there is a little bit more logic. So we don't want the camera to look over the negative side of the world. So which means I don't want the camera to go past here, right? So I don't want it to be like that. So whenever we touch the zero at the X axis, so we keep it at zero, okay? And in the example, I don't want camera to move up and down, just to keep it simple, right? So that was why I don't want to camera to move up and down. So that's why I always set the camera position at zero, which means it is always here, right? So do you see? Do you get it? So what happened if I do not lock the camera at the zero position, but instead following Mario, you will see a very annoying effect. Okay, so I'll do it now for you. So camera control is also a very important aspect of game designing. So if you have a very annoying camera, so it will be very hard to play the game. So and there with Mario 3, so because we have the area high at the cloud over there, so because Mario basically can fly a little bit, right? So you need to figure out how to do camera control better. So you need to know when to lock camera at the new position, right? So for example, if I let the camera to follow Mario strictly, right, on the Y axis, so you see what this will happen. So whenever I jump, so do you see something like that, right? Very annoying, right? So that was why we need to lock the camera. Do not change it too much, right? So when Mario jump, we do not change the camera to follow him, right? So we just lock it there. So, right? Now, what happens if I do not apply this camera lock logic over here? So you will see that we will look past to the zero area on the x-axis. So you can see like that, right? Mario is always at the center of the screen on the x-axis. So you can see it move, right? Okay, so that's it about camera. I will stop here for a minute and see if you guys have any questions. Any question? So if you continue to do your project, some might want to split the camera control code, little camera control code over here into a separate class, because actually you have to do camera control a little bit just like a normal object, right? You can think of a camera as a special object in the game where you do not actually render anything, but it is somewhat a game object because you have position, right? So if you look at camera as a, because camera has the position CX and CY, right? So you can move camera as if another object, right? So you can move it the way you want. You can animate it, right? Animate means by you change location of it over time. Like if you want to do the screen shake special effect, so you do so by changing the location of the camera object, right? So that was why, because I was lazy, right? So I just put camera as a CX and CY value inside the the game object over here, right? But this is not a very good way, right? So you might want to split the camera object onto another class, and because you have a lot of things to do with the camera, if you seriously about doing gaming, okay? Okay, so any questions so far? Well, I'm amazed that nobody asked any question again. Should I? It is so clear that you understand it all. Nobody has any question. Okay, so let's move on with the main topic of today. So to be honest, the topic is pretty short today as well, but it is important, and it is super easy to make a mistake in this lesson, so into your final project. So please be aware. So now we are talking about a scene manager, or a way to manage scene, or thinking it a different way as how do we store game data, how do we separate the game data from the code, right? So which is a very important aspect. So the reason here is on the screen. So usually when developing a game, so you don't really, so we usually have at least two groups of people. One is the developer who write code, just like us, right, doing the programming. And the other group at least is the game designer or the level designer or whatever, who design the game, who design the scenario, who design all of the levels, the world, right? And as you know, designer, so they are usually not very skillful in coding, and in fact, I don't think that real game designers need to know any coding, right? So these two groups work on a very different set of tools to achieve their goal, right? So for us developers, we work on coding. So we use Visual Studio, or we use whatever else, but mostly relating to coding. So you write code and you compile your code. So you organize source code. Basically, you work on the source code. Designer, on the other hand, they do not work with source code of the game. So because they don't know how to code, right? Usually. So they work with designer tools. Designer tools is whatever tools. It could be just Excel, could be just a text editor, but whatever tools. But the designer tools are completely different from the source code or the coding tools that the developers are using. So designer tools, what they are doing on the designer tools. So they use those tools to build the world, right? So they put a tree there, they put a Gumba over there. So they put a platform a moving platform over here. They put a trap over there, stuff like that. So they draw a cloud, which means they build the game world, right? So it has nothing to do with the coding, even though those two relating very closely with each other. So the result of the designer tools is what we call the game data, right? So a set of data to for the game engine to reconstruct the game world and execute it for the players to play. So developers, on the other hand, so the result, so they're working on the game source code, and they want, and the end result of that is a runtime engine. So either it could be a simple game or it could be an engine. So, and how the result of these two interact with each other. So the designer tools produce the game data, and the developers produce the game runtime engine, and the game runtime engines read the game data to construct, to build the virtual world for the player to play in, right? To play with. So is that clear for you? So usually we don't want, so the game designers, they don't really want to look at the game source code, or they don't know how to build the game code, right? So now let's take an example. So let's go back to our previous sample. Now let's say we have a little bit of the source code over here to define the sprite, to define the access for our Mario game, right? So if this were a real game, this will be it will be a very big problem, right? So let's say you and your friend is a game designer, your friend does not know how to do coding at all. So let's assume that he does not know how to even open Visual Studio and compile or build the game, right? So now every time he wants to put Mario or he wants to put a Goomba onto the game world, right? So what do you do? So we have a couple functions to put Mario, to put the game object onto the game world. So every time we want to put a Goomba over here, over there, we want to put a coin, right? So your friend, every time he wants to put an object onto the game. So what do he do? What does he do with the current situation? So given that he doesn't know how to compile the code, so what should he do? So the only choice is he has to go to you, right, and say, hey, my best friend, my savior, my developer, please open your source code, right, and put Mario over here at this location X, Y, and Z, right? And then yeah, so because you are friends, so you nice, you want to be nice, so you open your source code. A new Goomba appears there, all right? And then you go back to your programming life, so you continue working on the game. But and then after that, 5 minutes more, so your friend come back to your seat and say, hey, I think I make a mistake, so I don't want Goomba to be at that position anymore. So I want Goomba at a different position. So what should you do? So you say, okay, I have to move Goomba to a different location. And then up until a point, and then if your designer friend keep going back to you and ask you to change things for him, and then do you feel annoyed? Do you feel like, come on? So you need to find a way to let him do his job, and you keep doing your job without interfering each other, and even without knowing what you are doing, right? So that was why we need to build this model. So the game designer working on the game data, and you developers working on the game runtime, on the coding. So these two need not to collide with each other, need not to interfere with each other, right? So that you can move faster. So you don't feel this pain right now because you have never been in a real software development situation. So where different group of people have different roles, right? So and because you are just a student and you usually do everything by your own, right? So you don't feel pain. But in the real world, with a group of 100 of people working, like you have 100 of artists, like a few, like 20 game designers, and 100 code developers. So it would be so ugly if we put the game data inside the game itself like this. So there is a big pain in the ass, and there is a big, bad, very bad, super bad practice to put data inside the code. So we had to separate them, right? So that was why. So we had to build something to let the game engine to load all of the data from a file outside of the code so that it will run, right? Now, if we do it correctly, so we go back to the scene manager example, right? So we no longer see the code, the data inside the code, right? But all of the data has been put onto an external file over here, right? Where the object location are, uh, are put on a separate text file outside the source code. So your friend now can just work with the scene, right? With text file. So if he want to add a Goomba, if he want to add a coin, so he just go over here and edit the file, right? And we don't have to recompile the source code because the change he make, and he can just get a copy of your runtime engine and put it on his machine. So the exe file, not the source, the version with the source code, right? So he can get one copy of the binary files, and then he can work with the syntax file like this. Then you two can just go do what you do best without interfering with each other, right? So that was why keeping the data out of the game source code is so important. So I cannot stress enough that it is super important to do and must be done correctly. Okay, are you with me? Hold on, I have a phone call. Sorry. Okay, sorry guys. Oh, I missed my cat last week, right? Last week I remember seeing a cat. So who did that? Okay, so are we good? So do you understand the philosophy of why I'm so strict and super strict on what I will say over here, right? So I'll go back to this point later. But I want I want you to understand why there is such a strict rule of not to separate the game data from the game code itself, right? So do you have any question or problem with that up until this point? No, not at all. So you all agree, right? So you all understand the reason why we need to separate the game data out from the game source code, right? Okay, so that's great. So we will need to throw away all of the code as game data, right? So we need to separate them out and put them onto text file or onto some sort of a database. So don't think of database as SQL database or like SQL servers or MongoDB, stuff like that. So the terms database here is just a set of any storage way, any way you store data so that the data can be read back by the game engine, right? So it could be a source, a text file like this, a simple text file like this, or it could be an XML format, or it could be a JSON format, or it could be a real database. You guys can just use SQLite, right, or anything else, as long as by using those medium, so you can store data, and that the game can read the data back, right? Some of the game engine, so they do integrated environment where the game designer are using the same, almost the same tools as developers, but they do have a way to separate the data from the game source code, so that you don't have to include game data into the game source code, right? So that was the original intention, why I was so strict. So we need to do things correctly. Okay. Now, to illustrate a little bit on my point, so let's run the example and try to change something. Okay. So this is the example with with one simple screen with 5 coins, over here, right? So you might want to say, hey, teacher, I want another coin, right? I want another coin. So I want to add 2 more coins, I don't know, over there, right? So what should I do, right? So previously you have to go over your source code and make a change over here, I don't know where, over here, to add the coin, right? So which is very bad way. So in the example number 5, so you don't have to do that. So you go over here and you change. So actually it is at the scene number 2. So I will open it here, right? So you have 1 coin over here. So I will add another coin. So I will add another line of coin, right? So let's say it is at 100. I save it, right? I did not change my source code. Now I run it. So you see there is another line of coins appear here magically, right? So that's what I meant, right? So your friend game designer can work on the text file, add it, modify it, and you work on the coding. So you don't care. So as long as your friend follows the rules of the text file correctly, so your game engine will be able to read it and execute it nicely, right? So we have 10 coins. Okay. Are you with me? I know that I keep repeating myself, but I just want you to clearly understand the point made here. Any questions so far? Yes. Ask the question.
As you see, wait, just in the previous lesson, in Sprite lesson, I tried to load my map. Did you see that, right?
Yeah.
Yeah.
So you showed me the way you load the tile background, right?
Yeah. Is that a scenes manager, or some cap there?
Because no, scene manager is different. So scene manager allows you to load a scene, a level in terms of Mario. So you in Mario game, so you have many levels, right? Or many worlds. So you have world 1, world 1, 2, world 1, 3. So each of them is called a scenario or called a scene. So a scene manager is basically just like a texture manager, just allows you to have many scenes in the game and allows you to switch over them when something happens, right? So for Mario, so if Mario can reach the flag at the end of the scene, so we jump onto another scene, right?
Oh, I get it.
So scene manager is all about, you have a lot of scenes, just like texture. You have a lot of texture, so we call a texture manager is like basically you have a list of textures. So a scene here we have a list of scenes, and so you allow the system to switch and jump over each scene, depends on the game logic. Okay. Now, okay, so I'll explain a bit about the scene manager. So the idea of the scene manager is pretty simple. So as I just answer your friend over here, so we have different type of scenes in the game. So the most popular type of scene is the play scene. So a play scene is actually is a level in Mario's terms. So a world, so where the player actually play the game, right? Encounter challenge, kill Goomba, flying, doing stuff that a player is supposed to do in the game. So that is the most popular of play scene, right? So but we have many play scene, right? So each scene corresponding to one scenario, one level, one stage. What else do we have in terms of English word? So there are many terms referring to what we call as a scene, right? So you can name it. And we have different type of scene as well. Depend on the game, but for Mario, so we have two more type of scene. Actually four, but I don't want to mention the last. Is the star and intro scene, right? So this is the scene. Don't think of a scene as a game level, okay? So a scene is just a different way for player to interact with the game. So over here, a play scene. So you actually play the game. So that's why I call it to play. But for the star or introductory scene, we call it the where players actually interact with the game. It's just like a normal application where we have some beautiful animation, usually funny, to attract the players, and then you select the number of players as in the Mario case, right? So you select the number of players, or maybe you load or you save your game to go into the menu, stuff like that. So that is the intro scene. And Mario has a special type of scene, is a world map scene, where Mario can travel in a non-linear manner to different type of scene, right? To different place scene. For example, over here, Mario start with work 1-1, right? So after that, he has to go to work 1-2, right? But after that, he has two choices. So he either can go over 3, or he can go over 4, or if you want to be perfect, so you might want to go both scenes, right? But over here, so if you look at the map, it is clearly that he has a choice not to go to both 3 and 4, right? So he can go to either 3 or 4 or both, right? So, and then after that, he can go to the castle, and over here he go to 5 and go to 6, and so there is a branching here whether he want to go into a bonus scene, something like that. So we have different type of scene, okay? And again, play scene is still the most popular type scene. So what is a scene anyway? A scene is a specific way of interacting with the game, right? So again, world map scene allows you to select the destination, allows you to do something else. Play scene, you actually play or actually trying to play the game and to overcome the challenges thrown at you. And in the intro scene, you do something else. So there are a few more scenes that I can name here, like the game over scene, right? Game over scene is just like something displayed to you when the game, when Mario running out of life, so there is no more life to spend. Or maybe the end game scene where you see an animation or some sort of a storytelling scene with a little music where the princess kisses Mario, something like that. So we need a way to manage all of them, right? And in our technical terms, all of them are scene, but we have different scenes and different type of scene. So which means we have different subtype or the child class of the generic type scene. So in my example, I only implement play scene. So you need to implement the intro scene class and the work map scene class. Okay. Let's go into look at the code over here. Do you see my code? My code over here. So now we have a generic object, right? It's called a scene, right? So a scene is basically very simple. It's just basically a struct, right, to help us to associate the ID of the scene, right, and a scene file, so to store the data of the scene itself, and the key handler object. So why do we have that key handler inside each scene? Because if we go back to look at the different type of scene, right? So in the play scene, if you press a button like left, right, bottom, so you control Mario, right? So but if you are at the intro scene, so different keyboards, so you press the same key, but it means something different. Agree? So you don't control Mario in the intro scene. So basically, you press up down to select what you want to do. To select either it is a one-player game or two-player game or something. Agree? And even in the work map screen, so pressing up, down, left, right. So you still control Mario, but you can but the Mario here is controlled in a very different way as in another place in. So that was why the logic how to react to a key event is completely different from other type of scene. So that was why we need an object, a different object for each scene type. Okay, so that was why we need a key handler object to store here together with the scene. Still with me so far? Hello, are you guys still with me up to this point?
Yes, we're still with you.
Okay, so and we need to and when we run a scene, so the current scene become the game world. So that was why we need to implement the update and render function, right? So previously the update and render function is at the main level, but now we move the update and render logic into the scene object, right? So let's go over the main to see how it was changed. So over here, so you can see the render function. Oops, am I open the wrong one? Yep. So you can see that the core part of rendering is now moved to the render function of the current scene, right? So of course, every scene, every render function has to have these function called. So we don't want to change that. So but the exact logic of rendering a scene, now we move back to the scene object. Still with me? So same thing for update, right? So for updating the world, so now we move instead of processing the update over here, so we move the whole update back to the current scene, right? To the scene object. Okay. So that was the change. Now another type of And now, so how do we manage many scenes in a game? So assume that because again, as I mentioned earlier, so a game may have a lot of scenes, so we need a structure to store scenes, right? So it is 100% similar to Texter. So that was why we have a list of scenes over here, right? To be honest, I have to admit that I was lazy, so I need to uh, to be better in terms of architecturing the code. So we should create an object named scenes manager or scenes with a plural, right? Just exactly the same as the text. I was lazy, so I put it here. Okay, so just to make the change. So the same structure have an install in an order map with an ID, the scene, right? Have the which is the current scene being loaded or played, right? So and then we have another variable to tell user when Mario touch another touch a special object like the portal, right? And then we will switch to another scene, right? So this one to load to allow us to switch the string. I'll explain that later. Stay with me. Okay, so and then go back to the game object, right? So which has a very important function, which is the load function, right? Which is a load function. So what it does over here is simply read a special file here. So this file basically is the entry point to every data of the game. Think of the Mario sample.txt here file as a database, right? But this is the entry, the root of every data of the game, right? So and then the game engine only needs to know where to look for the database. So it does not need to know all of the other files because this file, so this Mario sample text file will have the data pointing to all other files if needed. That was why the game engine only needs to know the position of this file. So it does not need to know the position of other files because that information will be inside this file. Okay, so and then what it does, the load here is super simple. Now let's take a look at the file structure, right? So I haven't implemented these two settings, right? But I can get edit back very quickly. So instead of changing the screen width and height in the code, so we can change it over here. But anyway, so we have a general game setting. So the first setting, that's the only effective setting, is the starting scene. Right. So over here I say start at 2, means so down here we have a list of scenes, right, of the game. So we want to start at scene number 2, which means this one, right? Hello, I see some. Hello. Okay, good. So are you still with me? So the setting here, say the starting scene is with ID 2, which means I will start with at this position, right? With the scene number 2 here. And over here, down here, we have an area. So the portion. So there is a special syntax that I invented myself. So not actually, because if you look at this, so you might, if you were a Windows developer, so this is the format of the .ini file. But don't worry about that. So this is the format that I invented for this sample. Okay, so you can use different format if you like. So you can use XML, you can use JSON, or you can even use a real database if you want to. Okay, but it's just a way, one way to build the data, to build the database for the game. So the section, yeah, let's call it a section. A section over here is for a list of scenes that that is available in the game. So over here, I just put section scene 0 is the intro.txt, and if you look at my sample code, there is no such file. I haven't done it, so you should do it by yourself. But whatever. So we have 2 scenes, right? And we have the ID here, and over here is the name of the file, of the data file associated with the scene. And over here is a section to load on the textures of the game. So, you know, this is a small game, so it's okay to load all of the texture onto memory. So, but actually, if you want to optimize further, so you may want to put the section texture into individual scene file. Okay. Now that is the format of a of the main database. Still with me? And the code is simply, you know, the logic is very simple. So you go over line by line, right? So you read each line of the text file, and then if the text, and if a line starts with a pound sign, this character, so that is a comment line, just like our source code comment. So the function will just skip that line, so it doesn't process that line. So and then if it encounters the setting section, so it will mark that it is inside the setting section. That's it, right? And then after that, so if it does not encounter a section line, so which means it encounter a normal data section, which means it is somewhere down here, right? So and then because that we already marked the section we are in, so we know how to process, how to parse the data in each section. So in the let's jump into the section scene, right? So you can see that we use a utility function to split the line onto individual parts, right? So because one line here, so we separate the part by using the tab character. So the function split here basically, sorry, basically split a string into multiple parts, right? Into a vector of substring, each corresponding to a part of the string separated by tab character, right? So basically like that, and then after we get individual part, and then we convert them into ID, and then the path of the file, and then after that we create a new scene based on the data we read over here, right? So we read the ID, we read the name of the scene. Now notice there is a bug over here. So do you see that if for every scene I loaded, right? Every scene I loaded, so I assume it is a play scene, correct? Which is wrong. Sorry, I talk too much. Right? Which is wrong, because over here, if you look at the list, so there is an intro scene, which is a different type of scene. So how do we know which type of object we need to load over here? So probably you want to add another data field down here. Let's say you know that intro scene is of type, I don't know, 100, and play scene is of type 1, for example, like that. So you use the type here to know which scene you might want to create, right? Instead of me just creating a play scene object for every scene, so which is wrong. Okay, please make the note that this is not right. I have some people saying something. Okay, nothing, right? Are you still with me? So the next section is the texture section. Very straightforward. So for each texture we have the ID, and then we have the the path to the texture file as if it is as the own example. So nothing to tell over here. So if we look at the code, so you can see that the section texture is pretty straightforward as well, right? So we get the texture ID from the parts or the token. That's just my way of naming things. So we get the texture ID, we get the texture path, and then we call the utility function from the texture manager class to add the corresponding texture, right? That's it. So very straightforward, right? And now, so after loading the scene, right? So I call the logic switch scene. So how do I know that what is the current scene that I need to jump to, right? Because over here in the setting function, right? So if we have a line with a star, which is the star over here, so I know that the next scene value will be assigned to this value already, right? And then I assign it to the next scene. So the switch scene logic is very simple. If there is a differences between next scene and the current scene, it will jump onto the next scene. So that was why we can call the switch scene, which means we load the current scene, right? So the switch scene logic is also super simple. So basically, we unload the current scene if it is available, and then we set the key handler for the new scene, right? Because we already created the scene, but we haven't loaded the data. Remember that. So we created the scene, but without the data loaded. So now we just load the scene from the scene data file, and the scene is ready to go. Okay. So what does the scene file look like? So the scene file is basically the same, the same format as the main file, the main database file. So it's split into two sections. So the first section is access. Access means the sprite and animation. So and because of the scene 2, we need the access of Mario, we need the access of Koi, we need the access of the cloud object, right? So we have to put the name of these 3 files over here. And the next section, we have Mario at position 20 and 10. So as I comment over here, so we have 3 parts. So the first part is the type, so that we know which object we created when we read the line. And the second and the third parameter is simple, just the x and y. So over here we have the value is the coin. So we have at position 100 and 120 and keep going on. And we have a special object is a platform object. So the platform object has extra parameters, right? Like the x and y, the width and height of each cell, and the length of the cell, and the starting sprite, the ending sprite, and the middle sprite. Right? So if you don't know what is a platform object, go back and check at the collision sample. Okay, sample number 4. And if we look at the access file, so it is also super similar. So we have the sprite section, right? To list all of the sprite used by the object. Right? So we have the sprite ID, left, top, right, bottom, and the texture ID of the sprite, very similar to what we used to. And down here we have the animation, right? So the animation is the list of all animation. So an animation, we start with the animation ID, and then follow up by sprite ID and the time of the frame, and then sprite ID and time of that frame going on. Okay. So, and the logic to load an access is over here. So it's in the placing over here, right? Oops. Here is in the load access, right? So the load access function works similar. So you can see the same framework. So we go line by line and we identify the section, right? And then we know which section we are in. So we call the corresponding parsing function for each line in the data section. So, okay. So I think that's pretty much the core idea of the scene manager, right? Now, I will stop here for like a couple minutes for you to actually look at that and come up with any question possible, okay? I'll be back in like 3 minutes, okay? Hello, hello, I'm back here. So do you have any question for me?
Yes, I have a question about platform.
Okay, so
Can you open the scene to text the file scene to stack, and I will see your platform. Okay. I don't know why you set the value, the three value 5100.
Oh,
Yeah.
okay. So what is
You
a
can-
platform, right? Okay, let me explain. So, but before that, let's run the example. So do you see the cloud platform here?
Yes.
Okay. So why we call it a platform? Yeah, because it's just a very big. So right. So if we created a platform manually by by adding a lot of brick and stuff, it will be very long. So I'm become very lazy, right? So let's do something. Let's simplify the problem. So that was why we create a platform object. So basically, you can see the platform consists of, it is just a line of object, right? Agree?
Yes.
It is a line of object, but actually it is not. So it is a big object consists of smaller parts, right? So there is. So do you notice that the sprite down here, the sprite at the end is a little bit different from the sprite at the in the middle, right?
Yes.
Okay. So same applies for the sprite at the beginning. So the last three parameters are the sprites at the beginning, the sprite at the middle, and this the sprite at the end of the platform. Okay, the
Yeah.
ID of the sprite of the beginning of a platform object, and the middle, and the top. Sorry, the end. Okay.
Okay, I understand.
Okay, so we can play with the platform object for a little bit. So let's say I instead of starting at 0, we can start it at 100 and make sure that Mario did not fall down. So I will start it at 120. No. Okay. Save it. Right. So you see that the starting sprite is a little bit different, right? So to be flexible, we can completely use the brick object to make a platform, right? So if we have the brick, so I can include the brick object here, and we can use the sprite ID of a brick. So I don't remember, so I will open the brick object. So the sprite ID is 22 and 1, right? And then we open back here. So let's okay. So let's see how it works. So do you see that?
Yes, I see.
Starting. Okay, you got it, right?
Yeah.
So here's the endpoint. So the platform object is actually only one object, but the width is very big, right? It does not compose by multiple objects, right? So in fact, building a platform object is more efficient than scene. For example, if we go back to scene 1, where is it? Scene 1 here. So you can see I have a layer brick like that, which is very inefficient. But I just want to test the collision. That was why I create multiple objects like this. But we can easily use a platform object as in the scene number 1 here, right? So the X and Y over here is the width and height of each tile, right? And then there's the number of objects, small each tile, each sprite, to be correct. Okay, you're good?
Yes, I understand.
Okay, so how do we create different scenes? Do we create scenes based on their ID? Scene ID equal 1, scene what? Wait, I don't understand your question. So different scenes. So for example, you want to create another scene So by the current engine, so creating another scene is actually super simple, right? So I can create a scene for you right now. So as long as it is the same type of scene, right? Right now, my engine only supports play scene type, right? So we can do, if you want to create an intro scene or the work map scene, so you have to do it by yourself, okay? You have to figure out how to do it by yourself. But if you want to create another play scene, so if that was your question, so which is super simple. So by looking at the Mario sample here, right? So you want to do another scene, right? So let's say any ID you want, number 5. So you can scene, right? Okay, are we good? So I save it, and then of course I need to remember the 5 here, right? And this scene 2, I save it as scene 5, right? And yep. So and then how do we jump to scene 5, right? So we have a way to we can go back here. Where is it? I close it. Mario. So we can start with scene 5, right? But how do we differentiate scene 5 and scene 2? So let's create a platform. If I remember correctly, right? So we have this one, and we create another platform, 2 clouds. So is that 100, 8, for example. Now this is too high, so got it at okay. So then we can start the game. You see? Done. Creating another scene. Okay. Wait, did I answer your question? So there is no logic in the game. You don't need to. Now let's go back to the point I make here. So why I do not want you to do the hard-coded file name? Because again, so if you look at my sample code, so you see over here, so there is a little entry point, right? So the game engine load the database, right? So that is the only place where we need to know a file name, okay? We means the code need a hard-coded file name inside the source code. So and then you wonder, so how do I know where to load a texture, right? How do I know where to load a scene? All of that information is inside the sample, inside this file already here, right? So the name of all the files are all inside the database as the data itself. Okay, so there is no reason where you put another file name onto your game. Okay, so this is the only place where you put a file name because it is a entry point. So that's the strong point I want to make. You will die immediately if I found out another file name inside of any place, anywhere inside your source code. You die. Okay? Am I clear? Or do you understand why there is such a requirement? Hello? Hello?
Got it, sir.
Okay. So you I want you to make sure that you understand this requirement and you understand the original intention, why I want this. Okay, to keep that in mind. So I'm not irrational, right? I have good reason to ask you to do so in the real life. In real life, people do this. And this is a good practice. Okay? So game data and game logic should be separated. Okay? So game data should not be embedded into the game code. The same apply for any application. So usually application data should be separated into a database or into a configuration file. So maybe some of you know this already. So if you are building a real software, most configuration or most data string are exported onto a different access type, right? If you're on Android, it will be on an XML format. If you are doing iOS development, it will be on an XML format. So they are not inside the source code, not hard coded into the source code. So which is super important. Okay, the second point is that is a very, very common mistake, and I super hate this mistake coming from you, which is the scene-dependent logic of features. Okay, so what does that mean? Now, so usually when you code a game, code a scene, so you may run into something like this. So okay, I see that Goomba at this location, and it looks like that Goomba is specific to this scene. And then in the code, you say, okay, if the current scene is scene 1, you want to put the Goomba here at this location, right? And if the scene is 0, if you hit the Goomba, this Goomba will do something else. So you have some logic that's somewhat specific to a scene. And sometimes it is not wrong, you know, it is reasonable to do so, to associate a certain logic to a certain scene. If a good example is it's scene number 4 in work 1 or work 1-4. So in that scene or in that level, so the camera keep moving on to the right, right? So push Mario to moving on to the right, right? And some area in the hidden zone in scene 1-3, for example, the same thing applies. So the camera keep moving on to the right, right? And then to push Mario. So, and then you might want to put a logic into your code, like if the scene is 1-4, so you turn on the features camera moving, right? So do you see the problem with that? So what happens if the designer or your friend wants to apply that logic onto a different scene or onto a different area of the game, right? So do you have to open your source code and modify that logic, right? So which is wrong. So now the best way to do it is to try to put that logic onto the scene file itself, right? For example, you can introduce a new section of the scene file like this, of the scene data like this, right? Right? And then you can say camera move. You can say camera move on 1, something like that. So that feature will, and then if you you load a scene, and then you see that the camera move is equal to 1, and then you can turn on the features. So you don't have to if scene ID equal 1 inside your source code at all. Do you get my point here? Which is super important point. And another thing is, I think the most common mistake is the Mario starting location of the scene. Man, it is very classic, right? So over here, I already solved it to you, but previously without this, so you will be in big trouble. So let's say over here we know that Mario starting at 20 and 10, right? But on different scene, Mario may start at a different location. And then, before I introduce the sample to you, so a lot of you say, okay, if scene equal to 1, so Mario star is equal 20 and then and 10. And if scene is 2, Mario starting at 20 and 30 or something like that. So which is so ugly. Okay. The one I have just mentioned is the auto scroll camera, right? And the pipe transition. So if you code the work one-on-one, so there is a special area, so where Mario can stand on top of a very on a pipe in the cloud, and when he sits down, he will go into a hidden area, right? And then at that point you say, okay, that logic actually tied to work one, but it does not. That is a common logic. So that is a portal logic that I already introduced in the engine here. So whenever you touch something or you do something at a specific location, so you switch your Mario or your scene onto another scene. So that's it. So you can put that logic as data into the portal, into another object, into a a, uh, uh, a data of the scene. Okay, so I don't want to see scene dependent logic or feature. Okay, in short. So did I make myself clear over here?
Excuse me, sir. Please
Yes.
plot this line on course.
Yeah, actually, it is already there, but I modified a little bit. Okay, I'll do that very soon. Actually, why not doing it now? I think the slide is already there, right? So, wow, it's so slow. What happened? Everything is slow. Hold on. Give me a minute. I need to stop sharing my screen, otherwise it will become super slow. I think I already uploaded already, but so this class so the class 12. Okay, let me upload it to you. Class 12. Come on, why is it so slow? I think the slide is there. I just modified a little bit. Okay, but I can add another item. I can add it again. Man, that is so slow. What is going on? Wow. Looks like it is eating up all of my resource. Okay, I will delete this one. Okay, can you guys go over course and check if you receive it, if you have it? I'm running into a problem over here with my computer. It's become super slow. Not sure what is going on. Very slow.
Okay, see it. Thanks.
No window update. I don't think I run Windows update at the background. No, come on. I don't want to go to Windows 11. Oh, it's so slow. It's all right. I think yeah, I think that's pretty much for today. I don't want to go too fast, right? So we still had just one very short theory lesson on the space partitioning. Right? Sorry. I don't have any slide. So the content of the class, the class agenda is done, is over. So, but I'll just show the slide just for the sake of showing. Okay. Okay, as I mentioned earlier, so we basically will implement the intro scene, but keep in mind that the animation on the intro scene is optional. Why it is optional? Because it is a little bit complicated in terms of it is long and complicated, and yeah, it will eat up a lot of your time if you try to do that. So it is just for the student who want to be a perfectionist, right? So who want to get the 10 mark. Otherwise, you don't need it to finish your project. Okay. So we need to have the work map number one, which is exactly this one. So the work map functional. So you need to do that, and you need to implement map 1.1, which is a very basic and the introductory map to Mario. And then after that, there will be another map, but I will announce later. So previously it was map 1.3 and 1.4. So I will double check if map 1.5 or map 1.6 is doable, or the castle is doable for you, and then I'll inform you later. Okay. So on each map, so you need to implement all of the hidden zones. Okay. So which is a requirement. So you not only just the main area, but you need to implement the hidden zone, the hidden areas as well. Okay, any questions so far? Okay, so I want to spend the rest of the time, maybe 15-20 minutes left of today for you to just ask me questions. And any question coming up during the course up until this point, because I think after this, it is enough for you to do the project, to do the serious project. I will announce the checkpoints for you. So because we are in lockdown, so and then we might have more checkpoints than previous semester. Okay, so I will put it as assignments on the class on the course, so that you need to submit to give me the branch for each assignment. Okay, so research Git and give me the branch, so that I will go there and look at your progress. Git branch. Do you know what I'm talking about? Hello?
No. Sir.
Git branch. Just like on my Git example, so I have the main branch, right? The master branch, and I have the dextend branch. So basically, when you want to, when you want to split your development, so you want to give me your assignment, right? And then you will continue to working on your code. But I I don't have enough time to, to go immediately to your repository and look at the latest work of yours, or maybe it maybe even not working because you are working on it, right? So you branch it. So after you finish the assignment, so you branch the code out into another branch, just like a branch of a tree, right? And then that branch will stay there. So no matter what you do on the master branch, it doesn't affect. So I will go over the branch that you gave me and check out your progress over there. Kind of get it? So give me a Git branch of your repository. So I will announce what I want to see later.
How long it is, Tom, sir?
Yes.
How long the time you?
I have just said that I will announce when and what I want to see later. Don't worry, you will have enough time.
So we will push a branch. Which name after the deadline name?
Yeah, you can say so, or you can say milestone 1, milestone 2, whatever.
Yeah.
Okay, good question. Actually, I will give you the name of the branch. Fair?
Okay. Thank you, sir. Yeah.
Okay.
We need that.
When I put the announcement out, I will tell you what name of the branch you need to create. And be careful with Git branch. It is very convenient, but if you don't know what you are doing, you will fuck up everything. Okay? You will fuck up everything. But super be careful with the branching. You need to learn. You need to do some research on branching strategy. Okay? Keep it simple. Just a warning. Okay, I have a Git branch. Yeah, that's correct. Okay, any question on collision? I think collision handling is actually very complicated, but I'm quite amazed that nobody asked me anything. Or because it simply works and then you don't really care. Or you haven't done anything at all. So have you tried to put all the objects or try some complex things already? No? Not at all?
Sir.
Oh, space
Lab
partitioning.
question.
Uh-huh.
Yeah.
Grid. So the simplest type. No quadtree. I know that you will be suffer with quadtree, so we just use grid. Grid is good enough. Do you know what I mean? Grid. Lab. We will go over grid later, next class or maybe later, but not today. For you who doesn't know what grid means, but I'll go to that very soon, but not now. I don't want you to mess you up with this concept. So this is enough for you to build at least work 1-1 from my example. Okay, enough for you to do 1-1. Given that you need to implement the tile-based background, but even if you don't have the tile-based background, it's okay for you to temporarily use a background as a big image. Okay, I will accept that, but not for the final project. You will need to implement tile-based background, which is super simple. I even don't want to teach you on how to do that. You need to figure it out by yourself. Okay, so which is a simple thing. You need to figure it out by yourself. There are source code everywhere on the internet. You just go and grab it and modify it to fit your needs. But if you don't know how to do tile-based background, no, we won't. I want to keep your life simple. Okay, slope is very tricky to handle. I'll make sure that I will select a level which does not have slope. Good. What else? You have any question? Nothing at all. No question on the.
Excuse me. Can you go through this for me again? I think I don't quite get it in the collision one. The one with the direction of the slide about the direction of collision. Yeah, yes, this. Can you go over this for me again? I don't know understand what normal xy is it set as 1.0f sort of things. Yeah. Can you go over this for me again?
Sure. Okay. So let's say what is normal x equal 1 and normal y 0. So which is just the direction of the vector. Oops. Hello. Can you guys hear me? I think I lost connection. Just lost connection.
Yes, we can now.
Okay. You still see my screen?
Yes, I do.
Okay. So actually, I need to explain a little bit on the vector. So a vector is nothing more than just if you go back to a very basic definition of a vector is basically a point in place, right? So what do we call it? If a vector which has the value of x and y, so it is as simple as this, right? So I will draw. Hold on. I will get some drawing. You still see my screen? So,
yep, it still works.
Okay. So what is a vector? A vector is essentially a point in place. So why I say so, right? So a vector, as you can see, it has direction like that. So it is a vector, it is a vector, it is a vector, right? But on these three vectors, vector is for direction, right? But on these three vectors are the same. And we can normalize the vector to this one. So, and what is the x and y over here? X and y means this is the position of this point, and a vector pointing to x and y from 0, 0. So that's why we say this is a vector, or in short, we say vector x and y only, right? So we all know that this location here is 0, 0, right? You remember this very basic knowledge?
Yes.
Okay, so so we have a normal vector for a for an object. So we want to know which direction this object collide with this line, right? So we know which direction. So if we hit it down here, so we want to get the value of this vector, right? We want to return this vector or the normal vector. If we hit it here, right? So we want to return this vector, right? So if we hit it on top like this, so we want to return this vector. Are you still with me?
Yes.
Okay, so how do we, let's say, what is this vector, right? What is this vector? So if we map it over here, so this guy is down here. Oops. Right? And he's pointing down here. Okay, agree?
Yes. Oh, I see.
So
it.
what is the coordinate of this point? Is it -1? And x is 0, right? X
0
is
and
0.
-1, yes.
Over here is -1, right?
Yes.
Okay. So how about this? Same, right? So we want to return this guy. So that was why if we know that we are hitting at the bottom, so we want to return this vector, and this vector is x is 0, y is -1.
Oh, and it
Just
will
like,
tell the direction of the collision, right?
yeah. So usually we don't say we collide at the bottom, left, right, or top, right? But usually we want to know this vector. This vector is the reflection vector, so that we know how we usually push the object down to along this vector. That was why we want to get this vector rather than we know whether this is the top, bottom, or left or right. Get it?
Yeah,
So
yes. Thank you.
because when we hit at the bottom, we usually push the object down into this direction. Others, you have, do you understand? Hello, are we good? Nobody asking any question? Hold on, take your time. I'll be right here, waiting for you for about a few more minutes. Oh, okay, we are good. No more questions so far. Come on, guys. I keep saying this over and over again. You need to start with the project very soon. So 1 month has passed, right? So we are in the semester for 1 month already. So we only have 3 months left. So, and I know that you have a lot other projects to do, maybe. So, and heavy, very time-consuming project. So it's time for you to start coding right now, right after we finish this class. Grab my source code, trying to build work 1-1 as soon as you can, okay?
So how much time a day should we spend on game?
I estimated that you should spend around like at least 2 weeks of full working, so you can do the math, like full-time working. So a full-time employee usually spend around like 40 hours a week. So, a month. So usually you have to spend at least 160 hours, at least 160 hours actually working on this project in order to finish all of the requirement to get you to only 5. So highly recommend that you to start ASAP. Okay. So I just want to double check again. Do you understand this part of the collision stuff that we learned last week? So how to filter out the collision on x axis? if we just keep moving left, right, but we were pulled down by gravity like this. So you remember that part, right? And are you sure that you get it? Okay, no response. I assume that you get the point. Anything else on the source code that you want me to explain? Anything at all? Pain, of course. No pain, no gain. Have you ever heard of that term? So if you don't practice, if you don't really code and code the right way, there is no chance that you will be for you to become an awesome developer. So have you ever heard of a 10,000 hours rule? How do you pass through items without falling off the map? What? What do you mean with really? Pass through items without falling off the map. So pass through item, you mean like picking up like a mushroom or coin or stuff like that? Rick, can you explain further? Give me an example. So why we have to fall off the map when we hit an item? What was the problem? One of the mistakes that the old students usually make is they apply the collision framework without realizing what it does, which it is actually does. So usually in the previous semester, I only give you a sample of how to handle collision. Okay, it was not as good as this one, as the one you currently have. But over here, I'll show my code again. Let me share my screen. Let me share my. It's so slow. What is happening? Super slow. My computer is crashing. You see my coding screen?
Yeah, we see it.
So, do you notice that there is a compared to the previous semester? So you see the code to push back, right, over here, right? So in the previous example, because my sample was much simpler than this one, so I assume that all of the objects block. Okay, all object block, because I did not introduce the coin or the mushroom object in my example. I did not handle it, and you are the own student, you blindly apply the same logic, which means whenever you detect a collision, you push back, right? That was why you fall off the grid. So I'll give you an example here. Look at my screen again. But you don't have to push back all the time. Whenever you detect a collision, you need to make sure that the object you collide with push you back. Not every object. So one of the example is here. I'll show you on the screen. So I'll say, what the heck? It's better to share the whole screen. Okay, I'll create another example for you. see my my slide?
Yes.
Okay. Another bad example is in this case. So assume this yellow guy is a mushroom, right? So Mario is running over here, right? So the mushroom drop onto Mario, right? And the mushroom collide with Mario. But in the code, so we handle that Mario collide with the mushroom, right? We know that Mario collides with the mushroom, and because you apply the push for every object, and then when the mushroom goes down, it pushes Mario a little bit down into the platform like that. And then the next frame, so Mario no longer collide with the platform and it is just go down. Understand that, Vic? So in this example, in the current example, I already define an object. I already have a flat or I have a virtual function to identify which object is blocking or which one is not blocking. You can look at that over here. For each game object, right, we have a virtual function is blocking. So if this function for that type of object return true, which means the process function in the collision code will doing the pushing, right? So the whole logic of the collision here is mostly for pushing object, right? So we filter the object, the collision which push Mario or push the object back, and we only handle with the one pushing you. Now, if we go into the collision function, you will see that I only looking through the is blocking, the object returning is blocking to true. So if we don't see that, so we skip that object. Wait, are you with me? Wait, got it?
Can you explain it one more time, please?
Where did you lose? Like I say, like for like 10 minutes, and then you say you didn't get anything. So that was unfair to me, right? Now, slowly.
The blocking part.
So the blocking. So what is blocking, right? So if, for example, the platform is blocking, which means when Mario touch it, it will push Mario back. Okay, that is called blocking. With me, over here.
Yes.
Okay, so a mushroom or a coin, they are not blocking because a mushroom hit Mario, Mario will eat it, right? Or a coin, Mario hit the coin, so the coin do not or does not hit push Mario back, right? So that is not blocking. With me?
Yes, sir. Yes.
Okay, so now back to the logic. Why you have the problem of Mario falling down to the platform? Because previously you apply my sample code without understanding what it does, right? So because the sample code, as I clearly said again and again back there, say this is just an example. I temporarily say that everything blocks. So you say, and back at that time, the mushroom also block Mario. Okay, so the block Mario. Okay, and when the mushroom fall down, because the logic is if we hit an object which blocks Mario, we will push it back, right? Push Mario back. If we hit a platform, the platform will hit Mario, will push Mario back, right? So, and if the platform is here, we jump on, and then the platform will push Mario down. Agree? So that's one blocking. Now, what happened if the mushroom also blocking? Okay, so the mushroom goes down, and the mushroom hit Mario. But remember about the relative movement. Even though that the mushroom is moving, but in terms of collision, we say the mushrooms stay in one place, right? And Mario is actually moving in the reverse direction. Remember that?
Yes.
Okay, so in this case, so we think of the mushroom is staying here and Mario is moving, but in the reverse direction. So, and the mushroom moved down here, right? And it hit Mario. And because the mushroom blocked Mario, we apply the push logic and then we move Mario down here a little bit. And you can see that Mario overlapped with the platform down here, right? And in the next frame, because Mario already overlapped with the platform, the swap AABB will fail. It will say that there was no collision. And then because Mario does not have any collision, so it falls down. Okay?
Okay.
So that was the reason why we have the problem. But right now, the current framework, so if you define the mushroom is not blocking, you won't have this problem. Try it. So you can do it again. Okay?
Okay,
So
sir.
I was so upset that nobody, actually a lot of you not getting the point. So when I give you the example, you just blindly copy me. So without really understanding it, whatever I say, I keep saying that, no, this is just a sample code. You need to understand the logic behind it. But you keep doing the same mistake. That's okay. I correct it for you. Okay. Anyway, good question though. It's better to ask a question and then I'm just going crazy with that question. But at least you know, right? It's better to know rather than.
Sir, can
Yes, of course. Keep going on. Keep asking.
do during the working with project will there be a problem? So can we ask you
Of
by
course.
uh after is in the lesson in the class
Official
on the
class,
class,
right?
yeah, on
Yeah,
the,
go ahead. Just go ahead and ask. So, okay. So, after this class, so we will spend most of the time for question and answer and reviewing progress. Okay. So we don't really have new things to learn, right? So we will use this time every week for questions, and I'll try to help you. Okay. And that even if you have a problem, so you can send me a message on team. Okay, I will try privately or in a group. I would recommend to ask the question publicly. Why? Don't be shy, right? Because when you ask a question and you seems to be like you think that other people may think of you as a stupid person, don't think it that way, but think it in a positive way. So when you ask a question, and if your friends have the same problem, so your friend benefit from you, and if your friend is doing the same for you, so he asks a question that you may also have at the moment. So by me answering him, so and then I can help you, and also it helps reducing the effort of me trying to help you, and then I can spend more time helping people. Okay, so I recommend to ask the question publicly rather than send me a private email or private message. It's okay to do so, but I will, whenever I have a question, I will try to put it onto the public so that every people can benefit from it. Okay, get the point? So if you have a question, please, if possible, if you don't have any super sensitive problem with the problem with the question you want to ask me, make it public. Okay.
all right, we got it.
Mm-hmm. All right.
Teacher, what is the time of the first report?
The first report, I would think it would be about 2 weeks from now, maybe 3 weeks. Yeah, to give you a little bit more time. And I'll again, I will tell you what and when I will want to see things. Okay, and I will be very reasonable. I'm not asking you to do the impossible mission. No, I will ask you to do something a bit challenging, but not impossible. Looking at something about 3 weeks from now. Are we good now?
Yeah, of course. This is before we end the class, we're still good.
Okay. Yeah, we're still good until the end of this class, huh? Yeah.
There will be pain. Over 3 months of pain.
Yeah. Yeah. But you know what? It's just like doing exercise every day, man. So for every single day you keep trying, you don't even recognize the progress you make. But after 3 months, and even after you graduated, so you will appreciate the hard work you put onto this project. A lot of students who have graduated from the school coming back and even ask me not to be easy. Can you believe it? And he said that, yeah, because the course was so hard and they can overcome the hardship of the project of this course and they have grown up. So I know that sounds like, propaganda, right? Sounds like, moral lesson, but it is still true to some people, very true to some people. And when I plan to change the course a little bit to make it easier for you, just like trying to teach you how to use a game engine, right? Instead of trying to do everything from scratch like this, people say, no, 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 no. You should do that. You should not do that because you don't understand the core fundamental of game development. But how about stand up and sit down because Mario can be dropped through the platform? Yeah, it's true because the way because when Mario sit down, so you have to move Mario up and down a little bit, right? And if we are not careful enough, so you will move Mario down to the platform, and that was why he dropped out of the platform. But in my example, I already solved it for you. Try the latest example and see how I handle the Mario sitting and standing. Okay, Thiện. So, but that is actually a good question. I just want to address that. Now, so we think that doing Mario sit down and stand up isn't easy, right? No, it is not. So because the problem is this. Let me do. So when we draw something, right, the middle point is here, right? When Mario is down, so it is here, right? So when Mario sit down, so we might want to lower him a little bit, right? To lower him a little bit so that he will stay here. But because when we change the width and height of the bounding box, we might want to be very careful because if we make a mistake in calculation, or maybe you just +1 or +2 incorrectly, so the new bounding box of Mario at the sitting will actually overlap with the platform below, and as a result, it will fall down, right? So sitting is one thing. So and when you stand up, so you will have to move Mario a little bit up into the air, right? And adjust the bounding box. So you have to be careful with the adjusting the height of the bounding box. So if you calculate incorrectly, so Mario will overlap with the platform, and Mario will fall down. So it's all about that. So did I have the same problem? I did. Even me had the same problem when I first implement the feature as an example for you. But with just be careful with the bounding box a little bit, and you will be fine. Okay. And the example code is in my sample code. So just look at the way I handle Mario sit down and set up. Okay. Oh, and actually there was one funny bug of that. Let me put on the so don't handle Mario sit down on the key state function, okay? But handle Mario on the key down event instead of key state, right? Because whenever Mario sit down, right, we want to modify the location of Mario. We want to let him down a little bit, just like in this example, right? And modify the bounding box. So if we put the code into the state, the key state function, so that logic, the change location logic, will be executed many times, which means instead of changing only once, so you code it many times, and as a result, Mario will be pushed from here, and then in the next frame he will be moved down here, next frame he will be moved out here, and next frame like that, and then he eventually will fall down. Okay. Thiện, do you get the point? So again, look at my code. So there is the way I handle it for you. Okay, I think today I need to drop out a little bit sooner than usual. So hopefully that's okay for you.
Pardon me, but do you have time for one more question?
Sure.
Yeah. So you said that we use is blocking to know which one is can block Mario, but I searched through the text of your sample 5 and I don't see anything that is related to say an object blocked or not. So where do we set it?
Oh my gosh, I have just show you. Okay, look at my code here. Hello, do you see it?
Yeah, I see it.
This is a virtual function. So for each type of object, you either re-implemented it, or so by default everything is blocked, right? Now if you look at the coin object, right, so do you see that I changed it to not blocking?
Oh yeah, I see it now. I did. I think I did an update the sample. So yeah, I see the problem there.
Yeah. You need to get the latest source code from me. That is something very basic.
Sir.
Okay.
So what if you turn it into 1?
It will block and then it will push Mario, right?
Yeah, which means the con still turning around with animation, but when the Mario touch it, the road can pass through, right?
Mario is still can pass through because you, for example, if you turn the coin into blocking, it still work. But you will notice if you look at the when Mario jump and touch the coin, so you will see Mario is pushed back a little bit, and then he continue to move on because Mario still have velocity vector, right? So it still work in some case, but it will not. It will cause a problem of that your friend already encountered, like a mushroom drop down on Mario, and then it will push Mario down to the platform because that object is blocking. So if the object blocks, the framework will push, right? So let's say this is the coin, right? So when Mario jump over the coin, so if the coin is blocked, that's okay. You will see that Mario, if you look at the animation very closely, you will notice that Mario is kind of being stopped a little bit, and then he move on, and then he can eat the coin, right? That's okay. It's not a major annoying things for the coin, but for the mushroom, especially something drop down on Mario, so you will see Mario be pushed out the platform and fall off the platform. Here, I did not say that I recommend you not to use the key state. I only say that for the sit down and stand up features, we do not use the key state because it will cause the problem. Okay? So there are certain cases where key state is still good. For example, moving. So you can see that the moving, I'm still use the key state, right? Moving right and left, right? We still use key state, and I still use the jump, right? The jump and running fast and right. I'm still use the key state. No problem. But stand up and sit down, we use key event. But you were right. Almost a lot of keyboard events, keyboard handling, we mostly can do it with key event, not key state. Hiếu, are you good?
Yes, thank you, sir.
Okay, again, remember, for the stand up and sit down feature, so it's better to use key event, but it does not mean we will not use key state, right? Okay, I think that's it for today. I think I need to drop down. Okay, if you have any further question, either we can wait until the next class next week, or you can share me your message. I'll try to answer as soon as possible. Okay. So that's it. Have a good weekend and have a safe weekend. Okay.
Yes, you too, sir.
Bye bye.